Good morning, students. For the subject Engineering Mechanics, we are studying about the problems on properties of surfaces and solid. Now, let us solve the problem on moment of inertia of plane figures. So, this is the problem given. So, the image. See that this image is given. We have to find the moment of inertia of the section about its centroidal axis. We need to find the moment of inertia about the centroidal axis. First, we have to locate the centroid, right? Okay. For locating the centroid, we need a reference axis. Horizontal axis x and vertical axis y. And then we have to split the section into simple structures. So this is a complex structure. So how we can split this section into simple figures? So first we take this rectangle. Okay. So this is an object. So first we will take this rectangle, and then the second this triangle. Then we remove the semicircular shape. That's why we will get the required structure. So now we split the section into three. One rectangle, one triangle, and one semicircle. Okay. So first we take this rectangle and triangle. Then we remove the semicircular region. Okay. So removing means we have to subtract the values of the semicircles. Okay, for that we name the sections as first rectangle. I name it as section 1. It's a rectangle. Then I name the triangle as section 2, and then I name the semicircle as section 3. Then the areas, we can find the areas of the sections. So first rectangle, the area will be length into breadth. For area of the rectangle is length into breadth. Length will be 20 and height will be 18 for the rectangle. And then for the triangle, we know the formula for area of the triangle, which is half b heights. Half into base 20 into height of the triangle is 6 centimeter. Then after that, semicircle, area of the semicircle. What is the area of the semicircle? Which is half into pi r square. For circle it is pi r square. For semicircle it is half into pi r square. Here what is the radius? The diameter is 10 centimeter. In the figure it is diameter of the semicircle is 10 centimeters. Therefore the radius will be 5 centimeter. Okay. Then, so we found the individual areas of individual sections. Then after that, center points, centroid of individual sections. Okay. So now for the rectangle, what is the center point? So this is a center point. This is G1. G1 is the center point of the rectangle. That is center point of centroid of the rectangle G1, first section. Then this G2 is the center point of the triangle. Then G3 is the center point of the semicircle. Then for obtaining the centroid of the whole section, okay, we need to find these values x1, x2, x3, y1, y2, y3. So we know the formula, right? Formula for x bar as a1 x1 plus a2 x2 minus a3 x3 by a1 plus a2 minus a3. So here minus a3, minus means which is removed. So we take the rectangle as total. From the rectangle I am removing the semicircular region. So it is minus. So similarly we have the formula for y bar also. So in these formulas we need the values of x1, x2, x3. Then what is x1? What is x2? x3 means, so we take the reference axis, x axis and y axis. So x1, x2, x3 means from the reference axis, the distance along x, x1 means this distance along x, the center point g1. Okay, this is x1. What is this value? This value is midpoint, will be 20, so total 20, so midpoint means 10. Then x2, this distance, this also symmetry, it is 10 centimeter. Then x3 means this distance, okay, third center g3. So this distance is totally here 10. So for semicircle 5, 10 plus 5, it is 15. Then for y1, y2, y3, y1 means distance along y axis, right? y1 about the centroid. So this also totally height is 18, so it is value 9. Then y2 means this 18 plus this value is 1 by 3 of the distance, right? 1 by 3 of the height, so we'll find. Then y3 means this distance, okay, this distance, we know the formula for this distance of 4r by 3 pi, we will get. Okay, then we can substitute these values in centroid the section formula, we will get x bar and y bar. Okay, then we will get the center point, total center of the section, this is a center point, okay, this is a center point. So this is the total centroid G of the total section. Okay, this is x, reference centroidal axis through the center. So our question is, we have to find the moment of inertia about these reference axis xx and yy. Then we will solve the problem. So here for finding the moment of inertia, okay, this section, we have the formula Ixx means moment of inertia about the horizontal centroidal axis xx. Iyy means moment of inertia about the vertical centroidal axis. Okay, here we have three sections. So Ixx1, Ixx2, and this is subtracting, okay, removed section. So it is minus Ixx3. So here individually we have to find Ixx1 and Ixx2 and Ixx3. Ixx1 means first center, okay, first section. For the first section, what is the value? So for the first section, we have the formula Ixx1 is equal to Ixxg1 plus a into y1 minus y bar the whole square. So Ixxg1 means, okay, Ixxg1 means, okay, see this. So for the center G1, it is having a centroidal, horizontal and vertical. So, but we have a global centroid, that is Ixx and Yy. We need the moment of inertia about this section only, Ixx and Yy. But we know the formula of Ixx about its own centroidal axis. This horizontal axis only we know the formula. Okay, this you know the formula, we derived the formula for rectangles BDQ by 12. But we have to find the moment of inertia about this x. But we know the formula only for this, its own centroidal axis. So we have to use the parallel axis theorem. Okay, so here the parallel axis theorem states that, so about the axis plus area into distance between the axis. Okay, distance between the axis. So distance between the axis means, see this, so distance between the axis. So for the first section, y1 minus y bar. y1 means this distance, y bar means this distance. So we need this distance only, xx, this distance only. So this distance formula is y1 minus y bar the whole square, that's all. So we find the Ixx1. Okay, so this I, and also Iyy. Iyy means this axis. So the formula will be h bq by 12. So h means vertical dimensions, h into bq by 12 plus, so here x1 minus x bar the whole square, the distance, we need this distance, global yy and our local yy axis. We need the distance between them, that distance will be x1 minus x bar the whole square. Okay, so first section we found. For the second section, it's a triangle, right? Here also we have Ixx2 and Iy2. So Ixx about its own centroid. Own centroid means this own centroidal horizontal axis, but we need to centroid distance moment of inertia about the global xx. So we need this formula y2 minus y bar the whole square. We substitute it, we will get the value. So Iyy also we know the formula for that, hbq by 48, right? hbq by 48 only we have 48, hbq by 48 plus 60 into this distance, we will get Iy by 2. Then for the section, third section it is semicircular. Okay, semicircular region. So here about the central about this, horizontal xx we have 0.0068 d power 4 plus this distance square. So here also for about y axis, the moment of inertia is 5 d power 4 by 128. We will substitute y by 3. Then after that we can substitute in the formula Ixx is equal to first section plus second section minus third section, we will get the value. Iy also we will get the values. That's all. Then after that we solve another problem. Here for the same problem they are asking about to find the moment of inertia about its bottom edge. This is not about the local central axis, it is about the bottom edge. So bottom edge means this AB axis. How we can find? For AB axis. For AB axis, what is the, here also we have three sections. Okay. So we have this xx axis, local centroid, this xx axis, this xx axis. But we need to find the moment of inertia about the another axis which is parallel to the centroidal xx axis. That's all. Okay. Centroidal xx axis. This is parallel to the xx axis. Here IAB1 means IAB1, IAB2 minus IAB3. So three sections are there. So first section it is Ixx(g1) is equal to BHQ by the Ixx formula BHQ by 36 plus AH square. H means distance between its own centroidal axis and the axis about which we need to find the moment of inertia. So the distance xxx, this distance will be y1 distance, that is 9. So 9 square, area into 9 square we will get. Then for the second, this is the first section, right? So Ixx, so the distance between the parallel axis. So we need to find the moment of inertia about the required axis AB. So the distance between them will be the y1, that is midpoint of 18, 9 square. Then for the second section, so Ixx, about this axis the formula is BHQ by 36, but we need to moment of inertia about AB section. So the distance between these two will be, so up to this 18, so this is 1 by 3 of this 6, this distance. We will get the value. Then after that, for the third section, okay, third section which is a removed section, right? So semicircular region removed section. So here Ixx, about the xx axis this is a value. Then the distance between these two is a y3 value, that is 4r by 3 pi value. So we will get the value. Then we substitute all the values in the formula IAB1 plus IAB2 minus IAB3, we will get the value of the moment of inertia about the axis AB. That's all.